write down the homework assignment for 1-8. Here it is. Page 72. We started these notes yesterday, but I didn't give you the homework assignment yet. So,
why was that?
2 through, I don't know.
She probably knew that none of us were.
Had we
even
been,
gonna start.
we probably could have
24, 26,
I know,
50,
I wouldn't have understood it, but like, I
58.
was starting to panic. I was like, why don't
There he
I
is.
have any of this?
There's the homework assignment. If you need to pause, there he is.
72.
Beautiful.
20.
All right. We left off at
What?
log functions.
Yeah,
I
What?
wasn't
You
even
need
done
some?
yet.
Oh,
No, Eli
it's
has
right
it.
here.
Eli, do you need ibuprofen?
No.
Yes.
Oh, I thought that's what he just said.
Okay.
What?
Take some. I'm so confused. It's not poison.
All right. Log functions.
Yeah, ask Jalen about it.
We just talked about exponential functions. Like here's an example of an exponential function.
And say you're not
There you go. Write this off to the side. Exponential function.
Where?
I don't know. Off to the side over here. Right next to logarithmic functions. Where we're at. Okay, this is an exponential function. When we're trying to switch from an exponential function to a log, yeah, he
These are
starts
not
with a
bad.
log. What's the base of the log going to be?
2.
Dog.
Base 2 of
X equals Y.
Where are we?
y equals x.
Oh.
Second page.
The base stays the base. So the base number up here in the exponential function was 2. He goes down to the base of the log. And then the other two numbers switch. So if it was 2 to the x power, the x goes to the opposite side. The exponent becomes the equal to part. Okay? Got it? That's how that translates, okay? So like here, we have this stuff. There's 3 numbers. This is a log. The base of the log is 10. So if I'm switching him to an exponential function, he becomes 10 to the whatever power. What he's equal to is the exponent. And then the 100 comes to the other side. So 10 squared equals 100, which makes sense. This guy says 10 to the negative third power equals this guy, right?
Mm-hmm.
Now, does that make sense? That 10 to the negative third power would be 1 over 1,000, right? 10 to the positive third power is 1,000. Negative third is going to make him a fraction on the bottom. 2 to the fourth equals 16. That is true. B to the 0 power equals 1. I didn't even know what B is, but anything to 0 power is always 1. And then this one, B to the first power is B.
Yeah.
Yes. That works. Okay? So those are all switching from logs to exponential functions. A log function, well, an exponential function, look at this diagram right here. This exponential function is b to the x power. We said he always runs through 1 unless we move him up, down, left, or right. So this is like y equals, I don't know, 2 to the x power, let's say, right? The log of him would be log base 2 of x, okay? And he looks like this, and he's going to go through 1 on the x-axis. And you know that those are inverses of each other because they are reflections across the line y equals x. This little dotted line right here. Boop, boop, boop. He's like flipped over.
Reflection.
He's reflected over y equals x.
Y equals X.
Beautiful.
Okay.
Beautiful. Okay, they're flipped over. So an exponential function, he has a horizontal asymptote at y equals 0, but a log function is going to have a vertical asymptote at x equals 0.
So
Do you see that?
Has
So a log function has a va, an exponential has a ha.
a
Got it?
Say that one more time.
A log function has a va right here because the log is going to like suck down toward the x-axis or the y-axis. An exponential function is going to have a ha.
So
Maybe I should write that over here.
Yeah.
Exponential function has a ha
Okay.
at x equals 0. No, y equals 0. A log function has a va at x equals 0. Okay? That's what he is.
Oh, you made those shirts?
Vas and has.
Over the
All right?
No.
So here's more examples of log functions. So the first one, this blue one, you can't see in color on your page, sorry. This is log base 2. This one is log base e. This one's log base 4. And this one's log base 10. So we said the taller, the more narrow it is, the bigger the number. in this case, it's like the closer to the x-axis, right? Because that would be like narrow in log world. Okay? So the bigger the base, the more
Hang on,
upright
hold
he
up
is, I
1
guess.
minute, hold up.
Are we
Oh, wait,
solving
can you
for
go back
things?
to that?
Yeah,
Okay,
can
we
go
are.
back
We're
to the
solving.
graph?
I'm sorry. I'm just previewing. Okay.
Oh, okay, got it.
All right.
Hang on,
Good.
no. No.
My bad.
That's
Still
how
trying to-
it would him.
Clear that clog in my throat.
Okay, last guy.
Just take a
All right.
break.
Here we go.
Yeah.
Natural log. We've already talked about him. Natural log is log base what?
E.
ln is log base e. There he is. Okay. So when we are converting, always think ln log base e. That's what he means. Okay. So ln of 1 means log base e of 1. And if we switch him to an exponential function, the base is e, so he comes here, and this says e to the first power equals 1. That's what he looks like, okay? ln of e is saying log base e. E comes down here, e to the first power equals e. That's what he looks like, okay? This one is saying log base e, e to the negative first power equals 1 over e, is how we switch him. Log base e, e to the second power equals e to the second power. Okay, we're just switching them around. Okay, anytime you see an ln, just insert a log base e if you're going to move him around. Switch him to an exponential function. That's what he looks like. Okay, got it?
Sure.
All right, properties of logs. If we have like b to the 0 power equals 1 and we switch that to a log, the base is going to be b, and then these two numbers switch places. We've already said that. So b, log base b of 1 is 0, log base b of b is 1. Okay, now another thing that we can assume, if log base b of b is 1, it's almost as if these guys cancel out, right? That's the way that it works. So anytime your base is the same as the number you're taking the log of, that is going to transfer to be 1, okay?
So log
For
E of E is 1.
what?
Log E of E is 1.
Is 1. Log 17 of 17 is 1. Log 142 of 142 is 1.
Okay.
Log, yeah, you can't have negative logs, so I'm not even going to try that. Okay, anyway, exponential functions. We said he goes like this, right? And he has a ha. So I'm going to put him over here. The range for an exponential function is going from 0 to infinity. So he is saying the y's are greater than 0 is another way of saying that. Not equal to 0, greater than 0. The domain is going left and right forever, so he is all reals. Okay? For a log function, which does one of these, okay, he has a va, and his domain is going to be just x's that are greater than 0, because he's only going forever to the right, but he is going up and down forever, so his range is all reals. So if you notice, and this is the way that it works with all inverse functions, the domain and the range have switched places with each other. That will always be the case when you're dealing with inverse functions. So logs and exponential functions are inverses, their domain and range switch. So where it was y is greater than 0, now it's x greater than 0 for the domain, and the range went from all reals to whatever, right?
You using that to see the graph?
That's not right. They already switched it for us. So let's do this. I'm going to make my arrows go across from each other. They should go this way.
Oh no!
The range has become the domain, and the domain has become the range. So my arrows shouldn't have gone, whatever. Anyway, that's how that works. They're trying to confuse me. Okay? And we've already talked about the ha and the va thing. A log has a va, exponential function has a ha. Okay? All right, let's go down to, I don't know, this guy.
Wait,
This
what
guy,
did
if
his
he
graph
just,
do?
what? What?
What did his graph do?
What is this guy? Okay, there you go.
He went up.
All right, this bottom guy down here, if there is no base on your log, he is a base of 10, okay? So you can think about him like that. You can switch him to an exponential function if you want to. We just said if the bases are the same, then these cancel out, right? So all that you have left is x, right? Same thing here, if you have 10 to the power of log base 10, those are going to cancel out as well, and that's just going to be x. Okay, ln, which is log base e. Log base e and e are going to cancel out, so that's just x. E to the power of log base e, those are going to cancel, so that's just x. log base e of e to the 5th power, those are going to cancel, so the answer is just 5. E to the log base e, those are going to cancel, so the answer is just pi. Okay, now here's my question. Let's say we have e to the 2 ln x. Does e and ln cancel there?
No.
If the 2 is there. So what do we do then?
Can you cancel out one of them?
Can you divide by ln?
No?
Can you cancel out one of them?
Can you
Nope.
divide by 2?
Can you bring the
Can you take the 2 and the z off?
Yeah.
Can you bring the thingy thing? So 2 is already in the front, technically.
Can you bring it down?
Nope, you can't bring it down in front of the e.
When did you do that?
The whole thing.
When you ln both sides.
So if you have a log, here's the way that this works. If you have a log or an ln, and let's say you have an x and you have an x, and you have a number here, you can always bring them down into the front. Or if you have a number here, you can always put him back to the back. They're yeah, let's put him to the back. He's already down in front. Do you see him down in front? He can't go down in front of the e, but he can go to the back. Right? So this is x squared. So e to the power of ln of x squared, then the e and ln can cancel, and that just becomes x squared. Does that make sense? Okay? So just move him out of the way. If he's already down in front, put him to the back. Now, he does not go down in front of exponential functions. For example, like e, we couldn't put that 2 down in front of an e because this does not work. Are you ready? Let's say I have x to the 5th power. That is not the same thing as 5x, right? This is an exponential function, right? The 5s don't go between. But for a log function, it can. So that's why we can't take this 2 and put him down in front here, because x to the 5th and 5x are not the same. Got it?
Yeah.
Okay, so there's how that works. All right, let's talk about the product property. All right, let's do this. All right, product property. Here's how this works. Let's say I have log base 4 of x squared y to the 3rd. Okay, we'll just start with something kind of hard. And let's say I want to break that apart. Okay, x squared y to the 3rd. This is multiplication, right? And when we multiply him, multiply means add in log world. So when we break him apart into 2 pieces, he is log base 4 of x squared plus log base 4 of y cubed. Do you see how that works? Then if I'm this is called the process of expanding. When they say expand, this is what they mean, all right? Then I can do one more thing in my expansion, and that is to do what?
Move the number.
Move the numbers to the front. So I'm going to take 2 and I'm going to move 2 here, and I'm going to take this 3 and move him there. So I have 2 log base 4 of x plus 3 log base 4 of y. Does that make sense? That is fully expanded. We have gotten rid of the exponents in our log function. I'm going to steal this chair because I need to sit. Okay? Does that make sense? All right. Now, in the same way, the dividing, so I'm going to say log base 4, let's say, of x squared over y to the 3rd. In the same way as multiplying means add, dividing means subtract, right? So this is log base 4 of what?
X squared.
X squared is on top minus log base 4 of
Y to the 3rd.
y to the 3rd. But then those guys can come down in front, so I can put a 2 here and I can put a 3 here. And he's done. He's fully expanded. Okay?
Log to the 4th of x squared over y to the 3rd.
Mm-hmm. Yep. Now you can also condense. So if they give you the right side, you can put him back together and condense him. So we're expanding or condensing, either one. They work interchangeably. Minus means divide, multiply means add. Okay? All right. Are you ready for this one? The power property, I'm going to do this one over here. I like the power property. We just said that, let's say log base, I don't know, log base 2 of, well, let's just say log. Let's just say log instead of log base, so we don't have too many things. Log of x cubed. So that would be like log base 10 of x cubed. If there's no base, there's a 10 there, okay? We just said that he comes down and he becomes 3 log x. True? Like we just said that that's a thing, okay? Here is y. Are you ready for this? Log of x cubed means log of x times x times x, right? That's what x cubed means. Yeah? Okay, but what is times mean?
Multiply, and then
Add.
Add. So this is really log x plus
3.
log x
Oh.
plus log x. You see that? Because multiply means add. So if I separate them into pieces, there's log x, log x, log x. Well, what's log x plus log x plus log x? 3 log x. That's why. Because plus means multiply. Multiply means add, right? That this can transfer into this, okay? Which we already knew. We knew that that guy can come down in front, okay? Good? All right, and the last thing. Let's say we have a negative or we have a minus here, okay? So like negative log of, I'm just gonna say log base 2 of x, right? Okay? That negative is kind of like a -1 and he can go back to the back, right? Okay, but what's x to the negative first power look like if I want to make him positive? It would be 1 over x. So when you have negative exponents, you can make him into a thing like that, right? And that is legal. That's how that works. Okay? Kind of like minus means divide, right? And divide, I have division right here. This is divide. Okay, minus means divide. Okay? All right, let's do some examples. All right. Here we go. Example 2. Find x such that that is happening. All right. What would you like to do?
Change it.
What's the base, by the way?
10.
10. Okay, change it. If you get stuck, if you ever are stuck and you're like, I don't know how to solve for x, switch it to the other form. So right now it's a log, let's make it an exponential function. So what's the base? 10 to the square root of 2 equals x. Now can I solve for x?
Yeah.
Yeah, I just multiply them in my calculator. Does anybody have 10 to the square root of 2 that they want to type in and solve for me? I don't know what it would be.
I got 25.954.
Say what?
Yeah, let's go 4 decimal places because sometimes they do that in log world. 25.
25.9546.
Perfect. 25.9546. There we go. That's what x is. Okay. All right. Now, what should we do in B?
Change it. I don't know.
Yeah, okay, ln is the same thing as log e, right? Okay, now, knowing that, now let's switch him to an exponential function. So he will be what?
E to the 5th.
E to the 5th equals x plus 1. Okay, now, if I'm trying to solve for x, I'm going to calculate e to the 5th, whatever that is, and then I'm going to subtract 1, right? Minus 1, minus 1. So what is the e to the 5th, whatever that is, minus 1? A biggish number.
147.4132.
Perfect. There we go. 147.4132. Okay.
Yeah, x.
Yeah.
Yeah. All right. Now, C is in what form?
Exponential.
He's an exponential form. So let's make him a log. So this would be log base what? 5 of 7 equals x. Okay. Now, some of you guys' calculators you can change to log base 5, but if you can't, some of you guys' calculators only thinks in log base 10. What you can do instead is you can convert this to base 10, and we might go over this. We're going to convert to base 10. And the way you convert to base 10 is division. Log base 10 of something over log base 10 of something, and the 7 goes to the top because he's upstairs and the 5 is in the basement, so he goes down below. So all you have to do is type into your calculator log 7 divided by log 5 if you want to not have to change the base. Does that make sense?
Mm-hmm.
Some of you guys can change the base, that's fine. But log 7 divided by log 5, that'll do it. And you get something. If we had to make guesstimations, okay? 5 to what power gives me 7, right? 5 to the first power is going to give me 5. 5 to the second power is going to give me 25, right? 7 lives right here. So it's going to be a decimal number that's between 1 and 2, probably closer to 1, right? Okay, 1 point something.
2091. Yeah.
2091.
Yeah.
Perfect. There you go.
Change yours or did you just divide?
I don't know how to
Wait.
change it. I just
like this.
I just did the convert thing.
You guys have this.
I don't know how to do it though. Can I do it?
You don't know how to change a base?
What's the math?
Go to the math button and go to, what are some of the other ones? Maybe those are complex.
Number, complex, probability, fraction.
right, how's that? Let's see what else we got. Example 3.
I actually enjoy doing all
Okay.
Luke,
Example
are you
3.
signing up for my homework?
this. I do it for,
All right, a satellite that requires 7 watts of power to operate at full capacity is equipped with a radioisotope power supply whose power output is given by this equation, blah, blah, blah. Power is what P is. T is in time, and it says time is in days. How long can the satellite operate at full capacity? What's full capacity?
No idea.
7 watts of power to operate at full capacity. So we put 7 in for P, and then we solve. Okay, here's the deal. 7 equals 75 e to the negative t over 125. Okay? All right. Now what would we like to do?
Multiply by
Oh,
25.
We're going to
75, yeah.
divide by 75 first. We have to get rid of that operation first. You guys know this from trig probably. 75 divided by 5, or
7 divided
the
by
other way
7.
around. 7 divided by 75.
Did you hear about the metallic spheres found on the Pacific floor?
We don't care. What's 7 divided by 75? Somebody got it? What's that decimal?
Did we catch it?
7 divided by 75. 0.093 repeating.
0.093? Something like that?
Oh, we're just supposed to plug in.
What's
0.1?
repeating?
3.
We're trying to get the T down out of there,
Can we
right?
save it?
What? No.
Now don't you?
No, Ellen.
So now, I still am trying to get T down out of there, but he's in the exponent and I can't get him down.
So Ellen.
But I can get him down if I put an ln in front of both sides. They remember this from trig. You guys will go over this in trig. And now you'll know, okay? So if I do an ln in front of both sides, as long as I do it to both sides, it's legal. But ln and e are gonna cancel. So now I have ln of whatever that is equals negative t over 125, right? He is like come down off of the ln and e because ln and e cancel, okay? Then, after I get whatever ln of that is, I wanna get t by itself. I wanna get rid of the 125. So I'm going to multiply by 125 and
Multiply by negative.
I'm gonna multiply by the negative at the same time. So negative 125 times ln of whatever that junk is. That's gonna give me the time in days. How many days? Do ln of 0.09, whatever that number is, and then take it times negative 125. Somebody got the answer?
Yeah.
Yeah, what do you got?
296.4472.
We'll just go
365?
0.4. We'll just go 1 decimal place on the story problems. Especially if they're in days, that's not gonna really change a whole lot.
4 days.
We might go down to the second.
Okay, yeah, that's right. Okay, good, happy with that?
I think that's a good stopping
You
point.
think that's a good stopping point? You just don't, you just don't wanna get done
I'm getting.
with today's stuff.
Can we do
That's a
homework
lot.
tips for tomorrow?
What?
Can you please? I'm already getting clouded.
You're already getting clouded?
Yes.
Okay, sure, that's fine, we'll stop.
Thanks,
Okay, you should be able to get a start though on the homework problems.
You don't have a calc book in here?
Alright, goodbye, Haley.
I just